This film is a report by the United States Army on some of its various testing programs which ensure the American soldier of the best possible weapons and equipment. Like all tests, some were successful, some were not. Of the many weapons, materials, and methods you will see being tested, some have been discarded as not acceptable. But most have proved satisfactory and are used today in the military establishment or are being replaced by even more up-to-date equipment. For Army testing is a never-ending process of search and discovery, change and modification, so that the United States soldier can remain the most efficient, best-equipped fighting man in the world. Testing for tomorrow in U.S. military establishments throughout the country and abroad. A vast network of research laboratories and proving grounds dedicated to making certain that only the best military products and techniques are passed along to the American soldier in the field. At the Human Engineering Laboratories, Aberdeen, Maryland, a testing program basic to all Army activities. A study of the soldier's relationship to the weapons and equipment he must use and operate. Weapons do not fight alone, and in the planning of any weapons system, designers consider the human operator. A new type tank turret is being measured against this man in order to gauge his reactions to a low silhouette position. Latest scientific devices test the soldier's sensory reactions and his coordination ability. Technicians trained in this specialty conduct the human engineering experiments. Their findings will be used in construction or modification of weapons and vehicles. How will a soldier react under battle stress? How quickly will he be able to make vital combat decisions? These responses determine the fighting man's capabilities and limitations. The increasing complexity of military equipment makes it important to discover performance capabilities in advance. For example, can a soldier drive a test vehicle using infrared sensing devices? In applying the human factor to equipment design, human engineering fulfills a vital function. In field tests under various climatic conditions, the man-weapon combination is subjected to further testing to discover the soldier's capabilities in more realistic combat situations. For battlefield equipment must be operated and maintained by men under extremes of physical and mental stress. The soldier's ability to do his job depends to a great extent upon his endurance. The U.S. Army Polar Research Program includes tests for stress and strain factors in northern latitudes. Conversely, effects of extreme heat are determined in training experiments in the desert areas of the Southwest. Here, servicemen are carefully studied for reaction to high temperature. Desert tests supply data important in the design of hot weather clothing and in determining the fighting man's physical capabilities under heat conditions. Testing comes in small sizes too. Which are the best chemicals to make drinking water safe? Both at home and abroad, U.S. Army technicians and scientists carry on continuous research to ensure the health of the American soldier and his ability to carry out his global mission. Various Army testing laboratories are concerned with the great variety of supplies required by our modern fighting force. At an Army research center at Natick, Massachusetts, many of the materials the soldier needs in battle are tested. Here are developed the quality standards and specifications for the soldier's clothing and footwear to make sure they will withstand the rugged use they'll receive in combat. Climatic test chambers simulate weather conditions to which the soldier's clothing may be exposed. Resistance of clothing to cold and moisture are critical factors in outfitting the Army. For the American fighting man today must be an all-weather soldier, capable of doing his job under any possible environmental condition. Developing food packaging procedures to meet demanding military needs is an important Army assignment. One process investigated was research into irradiation of test rations for more varied menus and to determine the practicality of long-term, non-refrigerated storage of vital food stocks. What the well-dressed fireman will wear, Army style. Testing of lightweight aluminized suits for firefighting. A practical workout for soldiers and a definite breakthrough with direct application to civilian firefighters. The soldier's ability to conduct operations in water was tested at Fort Belvoir, Virginia. Result, the now famous cold bar clothing, which provides thorough insulation against icy water. Today's Army maneuvers often require activities in water, and the cold bar suits are designed especially for these tasks. At the Army Engineers Permafrost Laboratory, Wilmette, Illinois, the effects of frost are continuously studied. Tests here help determine specifications for equipment and materials to be used in U.S. military activities in the Arctic. Exercises at our nation's critical northern outpost provide a rigorous test for both men and materials. Alaska, 1956, Operation Moosehorn. Maneuvers to find answers to the question, how best can we meet our military commitments in the Arctic? Field problems here tested our capability of supporting weapons and moving supplies under extreme climatic conditions. Temperatures in this area drop to 60 degrees below zero with accompanying high-velocity winds. 30 to 40 inches of snow offer a vigorous test of cross-country mobility for military equipment. All full-scale Army exercises offer the double advantage of trying out new tactical battle concepts and field testing and evaluating the performance capability of the articles and weapons the soldier must use. Moving tomorrow's Army is a task of great concern to military planners. Tests conducted on various types of snow vehicles point the way toward new and improved Arctic transportation. If trucks bog down, are snow sleds the answer? Army planners will find out through constant research. A team of transportation experts takes off across the Greenland ice cap to determine depth and resistance of snow. Vital data for the movement of heavy military supplies across Arctic terrain. Sensitive electronic equipment secured to the testing vehicle will plot the path. Critical to Arctic transport operations is ability to detect and expose dangerous crevices in the ice cap. Technicians probe for hazardous ice cuts. Testing of all types of vehicles needed to support our increasingly mobile Army is continuously carried on. Here is a fuel tanker in a river crossing test. Expert Army drivers put heavy transportation vehicles through trial runs on test courses. Size of equipment is no barrier. Performance is carefully observed, and any mechanical defects or flaws in design are referred back to the appropriate agency for further development and testing. At the Army's Mobility Command in Detroit, problems of vehicle traction are scientifically studied. Here, mobility is a challenge, and the determination of what type of traction is best suited to a particular vehicle is made in minute studies on model equipment. Soil mixtures from all parts of the world are prepared for precise traction experiments. Terrain conditions similar to those where the vehicle may be used are simulated on test tables. Because many Army vehicles must also be capable of limited water operation, the Detroit Arsenal Research Division conducts scale tests on mobility of equipment in water, a step in the development of the vehicle prior to production. Then a pilot model of the vehicle gets a workout under field conditions and proves itself. Test ranges put many types of pilot models through demanding runs over a variety of obstacle courses. The testing process is carried through with further trial runs. These tests on Fort Knox's ranges prove the need for a more powerful tank. Already in early stages of development, the new improved tank went into competitive testing at the Aberdeen Proving Ground. With greater firepower, the M60 took its place in America's armament inventory. Army research experts seek constantly to develop devices that will help get the job done faster, safer, and more efficiently. This robot tractor was an early experiment in the search for a way to clear a path under enemy fire without hazard to a driver. A ditch digger which may be delivered to the combat zone by air can carve out trenches for the soldier in a fraction of the time it would take by hand. Amphibious actions played an important role in World War II. Important data on waves and tides, vital to landing operations, are compiled by U.S. Army engineers. By means of wave-making apparatus, artificially induced waves roll down an experimental channel as depth variations are studied. Recovery of disabled equipment is an essential combat assignment. This landing craft retriever, shown in tests at Fort Story, Virginia, can speedily right a capsized or broached landing craft, or remove one that is disabled and impeding landing operations. The vehicle is 75 feet long, 38 feet wide, and weighs 101 tons. Its 10-foot high tires, among the largest ever manufactured, enable the retriever to travel with ease over soft, sandy beach. Nicknamed Beach Buggy, the retriever was designed to operate successfully in up to 8 feet of water. Easily maneuverable, it can be controlled by one operator and can lift landing craft weighing up to 78 tons. The retriever can be taken apart in sections, moved by flat car or trailer, and be assembled at its destination. Success in battle may hang on the crossing of a river swiftly and in force. U.S. Army engineers perform a test problem in assembling a bridge for heavy equipment during field testing exercises in Germany. Mobile assault bridging for rapid water crossing is constantly under development and test by the engineers who give logistical support in moving the Army to its military objectives. The Army laboratory is as wide in scope as the variety of weapons, equipments, and methods it examines. In a new concept of speeding up supply operations for beachhead landings where no fixed port facilities exist, Army and Navy join forces in a roll-on, roll-off test on Chesapeake Bay to determine the feasibility of transferring military vehicles between vessels at sea. By means of a specially hinged ramp bridging the vessel's sterns, vehicles loaded on board the larger ship move with their drivers and crews onto allotted spaces on the flat-topped deck of the smaller Army vessel. In actual operation, the Army ship would then proceed to the beach, lower its bow ramp, and the vehicles would roll over the beach to their final destination. The U.S. Army Signal Corps laboratories at Fort Monmouth, New Jersey, conduct extensive testing in the vital area of communications and electronics. One end product of Signal Corps research and testing is a global communications network utilizing the teletypewriter as its basic tool. The standard teletype has provided great flexibility in sending Army messages. The modern Army Communications Center can handle over 250,000 messages a day. Yet even this type of equipment is being continuously revised with even more flexible electronic communication developments. At Fort Huachuca, Arizona, the Army Electronic and Communications Proving Ground has long conducted full field tests of signal equipment. The basic questions: how will our communications equipment bear up in combat, and what can we do to improve it? For example, this remote control photo reconnaissance drone can take pictures over enemy territory.